Hello my dear students. So in this session I am going to start with elementary quantum mechanics. So this is under chemistry paper 6 unit 1 chapter 1.1. So what is meant by elementary quantum mechanics? So before understanding what is meant by elementary quantum mechanics, so this is the topic which comes under quantum chemistry. We'll understand what is meant by quantum chemistry first. So quantum chemistry, it is also called as molecular quantum mechanics. So it is a branch of chemistry which is focused on the application of quantum mechanics in physical models and experiments of chemical systems. Okay, so that means as you hear the word mechanics, so it is completely based on the concepts of physics. So in this quantum chemistry, we are going to use some concepts of physics which will be helpful for us to understand the electronic structure and molecular dynamics of a particular atom or molecule or a compound. Okay, so mainly we concentrate on Schrödinger equation. The Schrödinger equation is also called as Schrödinger wave equation. So you might have studied in physics, so where you are going to prove with the help of this quantum mechanics, that is the dual nature of light or matter. Okay, so that is the light, it has dual nature, that is it can also act as a wave. In the same way it can also act as a particle. We can consider light as a particle as well as a wave. So this is what is called as dual nature of light. Okay, so this quantum mechanics helps us to study or to understand the electronic structure and molecular dynamics using the Schrödinger equation as a central topic in quantum chemistry. Okay, so this is what is meant by elementary quantum mechanics. Chemists, usually the researchers, they rely upon spectroscopy through which the information regarding the quantization of energy on a molecule or a molecular scale can be obtained. Okay, so if we consider the spectroscopic experiment what we are going to do, so there light radiation will fall upon the substance, okay, or the compound which is under examination. So that will absorb the light energy. What happens there? So the electron will get quantized. That means quantized means a certain amount of quanta. Quanta is nothing but photons. It is a energy in terms of light is absorbed by the substance, and they will excite from lower energy state to the higher energy state. So all these electronic transitions are understood with the help of spectroscopy, right? So here how the quantization of energy is going to take place. So all these things can be deeply studied by studying it in terms of quantum chemistry or elementary quantum mechanics. Okay, so the common methods which we are going to use is infrared spectroscopy or IR spectroscopy, nuclear magnetic resonance spectroscopy, and scanning probe microscopy. So all these different types of microscopic techniques are used through which the information regarding the quantization is studied. Okay, so what happens here is the quantum chemistry, exactly it studies the ground state of individual atoms and molecules and the excited states and transition states that occur during chemical reactions. Okay, so for this purpose it is very important for us to understand the concepts of elementary quantum mechanics. Okay, so now let us move on to the introduction part of elementary quantum mechanics. So what is the need for elementary quantum mechanics? So before understanding that, mainly we have two different types of mechanics or quantum mechanics. What are those two different types of mechanics are? One is classical mechanics and another one is quantum mechanics. So it is essential to understand what is classical mechanics and what are its limitations. Only then we will find what is superior in terms of quantum mechanics. Okay, so if we know the limitations of classical mechanics, then only it is meaningful for us to understand what is quantum mechanics in a better way. So what is meant by classical mechanics? So mainly in classical mechanics and quantum mechanics, so mechanics is the term which is very common. What is meant by mechanics? So the study of science of motion is called as mechanics. Okay, it is a study of science of motion, how the movement or motion is going to take place. So that is studied. So that is why the name mechanics. As I said, mainly there are two different types of mechanics. One is classical mechanics and another one is quantum mechanics. Classical mechanics describes the motion of macroscopic objects. What are macroscopic objects? So those objects which are measurable or observable by naked eyes. Okay, so if we see it through our naked eyes, so such objects are called as macroscopic objects, whereas quantum mechanics describes the behavior of systems at atomic length scales and smaller. Okay, so in this universe there are huge objects like planets and stars. So there are also subatomic particles like protons and neutrons. So we may not able to see the subatomic sizes, the wave nature of the particles that cannot be neglected, and that the particles move at very high speed. Okay, so usually when there is a smaller size, then it will move in a very high speed. Okay, so that you can compare in your daily life also. So if you consider a football or a throw ball, with that with your cricket ball. Okay, so a cricket ball is very small compared to the size of a throw ball. So you cannot throw both the balls, that is a throw ball and a cricket ball, in same distance. That means throw ball could not be thrown very far. How much you are going to throw the cricket ball? Okay, so in this way the size differs. So the planets and stars, they move slowly compared to the speed of subatomic sizes, or the nature of the particles which have very less size, smaller size, so they will have very high speeds. So which theory of physics explains satisfactorily the behavior of both? So if you want to study the behavior of both, then definitely we have to use both classical mechanics and quantum mechanics. Whereas we are concentrated only on the atoms or electrons, okay, so which are in terms of atomic sizes, very smaller sizes. So definitely we have to rely upon quantum mechanics, which is considered only for microscopic objects. So quantum mechanics has much more complicated theories than classical mechanics. All credits goes to Einstein, but it provides accurate results for the particles of even very small sizes. Quantum mechanics handles the wave particle duality of atoms and molecules. Okay, so this is why the classical mechanics finds some limitations in explaining how the wave particle duality is studied in terms of chemistry. So as I said, so the branch of science which is based on Newton's law of motion and Maxwell's electromagnetic wave theory to explain the phenomenon related to motion and energy is known as classical mechanics, or it is also called as Newtonian mechanics. So it assumes that energy is emitted or absorbed in a continuous manner. So according to the Newtonian mechanics or classical mechanics, so the energy is emitted or absorbed in a continuous manner. Whereas quantum mechanics says that emission or absorption of energy takes place in discontinuous manner in the form of packets of energy, which is called as quanta. Okay, so packets of energy will be there. So many number of quanta will combine or will come together, and that will be emitted or absorbed in terms of energy. Okay, so that is what the quantum mechanics explains about. And the classic mechanics as formulated by Sir Isaac Newton is obeyed by only macroscopic particles such as planets and rigid bodies. Okay, so this is where the limitation of classical mechanics lies. However, since microscopic particles show wave particle duality, so they do not obey Newtonian dynamics. They however obey the quantum mechanics, or it is also called as wave mechanics. Okay, so this is what about classical mechanics and its limitations. Next is classical mechanics. It does not provide satisfactory explanation for the following phenomena. One is black body spectrum, okay, or it is also called as black body radiation, photoelectric effect, atomic and molecular spectra, heat capacities of solids. So these are the various different concepts in which the classical mechanics does not provide satisfactory or acceptable explanations in the phenomenons. So the quantum mechanics or wave mechanics, it takes de Broglie's dual nature of matter. So this is also, I hope you have studied in physics what is meant by de Broglie's dual nature of matter, and also the Heisenberg's uncertainty principle into account. Okay, so the Heisenberg's uncertainty principle is a very interesting topic in quantum mechanics, where it explains that we cannot identify or we cannot measure the speed and mass or size of the particle simultaneously, or at a time we cannot measure it. So if we concentrate on measuring the mass of the particle, definitely the speed or the motion will be neglected or negligible. Or if we concentrate on measuring the motion or speed of a particle, then definitely the mass of the particle or size of the particle is going to get neglected. Okay, so in this way the de Broglie's dual nature of matter and also Heisenberg's uncertainty principle is main concepts to understand the mechanics, that especially the wave mechanics in terms of elementary quantum mechanics. So this new approach to the study of particles of atomic dimensions, it provides a satisfactory basis for many of the phenomena which are not satisfactorily explained by the classical mechanics. Okay, so these are the main different concepts or the phenomena which could not be satisfactorily explained by considering the classical mechanics. Whereas if we study these black body radiation, photoelectric effect and atomic molecular spectra or heat capacities of solids, considering the wave mechanics which takes de Broglie's dual nature of matter and also Heisenberg's uncertainty principle into account, so definitely the explanations which we can give to explain these four different phenomena could be be more meaningful, and also it will be more acceptable explanations. Okay, so this is what the limitations of classical mechanics explains about, and in that way growth of elementary quantum mechanics was absorbed. Okay, so now we will see one by one how we are going to understand the black body radiation and or a black body, what is meant by black body. Okay, so very important is what is meant by black body or radiation. So this black body radiation is the thermal electromagnetic radiation within or surrounding a body in thermodynamic equilibrium with its environment emitted by a black body. Okay. So what is meant by a black body? A body which completely absorbs the radiant energy falling on it is called a perfectly black body. So that is why usually I don't know how whether it is absorbed in this area. Usually in Mysore or in my native there, our elders say that in summer don't wear black cloths or don't use black objects or materials or cloths, or don't stand under any black roof or surface. Why it is? It is because the black body or the color black, it has the capacity to absorb the radiant energy which is falling on it. So in the same way, a body which completely absorbs the radiant energy which is falling on it is called as a perfectly black body. For example, so if the radiant energy is allowed to fall on the blackened metallic surface or carbon black, so it is found that the energy is almost completely absorbed. A black body is not only a perfect absorber but also a perfect emitter of radiation. This is very, very important. So a black body does not only absorb the radiation energy but also it is a perfect emitter of radiation. Thus, of all the bodies heated to a given temperature, maximum energy is emitted by a black body. The radiations thus emitted are called as black body radiations. So those radiations which fall upon a black body and they gets emitted out. So such type of radiation, such type of emitted radiations are called as black body radiations. And these radiations are emitted by any solid at any temperature as a result of the vibrations of its particles are called as oscillators. Okay, so this is what we have to understand before moving on to perfect black body radiation. So what is meant by a perfect black body radiation? So this is the figure which shows a perfect black body. So if we observe this figure, so here H and H, so here incident radiation has been allowed to proceed inside the black body radiation. A perfect black body is a hollow tube or a double-walled metallic sphere which is having a conical projection P. So this is conical projection P. Okay. So I have named it as P, and it has got opposite hole which is represented as the capital H, and the whole thing is coated on the inside with lamp black. Okay, so lamp black has been coated inside this. So the experimental setup to conduct a black body radiation is, so we should have a hollow double walled metallic sphere which has a canonical or conical projection, and all the inside, the interior wall, the inside wall should be coated with the lamp black. Okay. So here what happens is the radiation entering the chamber through the hole, through this hole. Okay, so here you can see. So here this is what the incident radiation. So from here the radiation is entering the chamber through the hole, is absorbed completely due to repeated reflections inside the enclosure. Why the repeated reflections is absorbed? As I said, a black body, so it is a good absorber in the same way. So it has the tendency to give back or to reflect or to emit the radiation which it is going to absorb. Okay, so that is why we can see repeated reflections inside the enclosure. The radiation emerging from the small hole of such a hollow enclosure is called as black body radiation. So the what radiation which is going to emerge from the small hole of such a hollow enclosure, so therefore that radiation is called as a black body radiation. Okay, so this is what about black body radiation. So what are the spectral distributions we can see in black body radiation, and what are the characteristics of the curves in this black body radiation? All these things we will discuss in my next class. Okay, so in this class to make it a summary, so I gave you a brief introduction about what is meant by elementary quantum mechanics. Okay, so there quantum chemistry or quantum mechanics is the study of molecular structure or electronic transition of atoms or molecules with respect to the chemistry by using Schrodinger wave equation. So that is what is called as quantum chemistry, and mainly we classify mechanics into two types. One is classical mechanics and another one is quantum mechanics. And what are the limitations of classical mechanics? What is the need for the development of elementary quantum mechanics? So that was understood in this session. And mainly there are four different concepts or phenomena which could not be explained by using classical mechanics. So in that the first one is black body spectrum or black body radiation. So what is meant by a black body and what are black body radiations, so that I explained in this class. And as I said, so the spectral distribution and the characteristic of the curves, so I will explain it in my next class. Okay, so thank you dear students.